Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today I will be talking about the phosphate phosphorus release paper entitled uh, phosphorus release from sewage sludge and digested driven by biological sulfate reaction. Effect of feed sulfate concentration and thermal hydrolysis. The work is published in Environmental Science, Water Research and Technology. Royal Society of Chemistry. This phosphorus release from sewage sludge and digested driven by biological sulfate production. Effect of feed sulfate concentration and thermal hydrolysis. Phosphorus recovery from waste streams standard as a strange to ensure phosphorus availability to future generations. The release of phosphate mediated by biological sulfate reduction is an investing by process for phosphate recovery from sewage sludge in wastewater treatment plants in which chemical phosphorus recovery is foreseen. This study investigates the effect of biological sulfate reduction, a different feed sulfate concentration on the phosphate release from both sewage sludge and digestate, as well as the impact of sulfate addition on energy recovery from the sludge by methane production. During anaerobic digestion, up to 63% of the phosphate initially present in the sludge as iron phosphate was released with 8,000 milligrams per liter feed sulfate. However, biomethane's production was significantly reduced when sulfate was added at concentration above 100 mg per liter. The use of thermal hydrolysis on the sludge digested was found to be an effective strategy for phosphorus recovery from the sludge without compromising the biomethane production during anaerobic digestion. A phosphate release from iron phosphate up to 38 was obtained. The modern paradigm of circular economy, the recovery of waste materials, has become of utmost importance to reduce the depletion of natural resources and environmental pollution. In this concept, this wastewater treatment plant can be considered as a source of valuable materials and energy to be recovered rather than discarded along with the effluent. The in the modern paradigm of the recovery of materials, depletion is among primary to travel. There are several points sustainable goals obtained by improper phosphorus management can lead to serious problems such as eutrophication. First discharge in European country, the work is by by Papilio from Naples University. The Papilio found that for wastewater treatment, phosphate removal is based on addition of multivalent metal, which acts as precipitators of phosphate ions before or after the biological stage, resulting in phosphorus recovery from 65 to 99%. Phosphate recovery, a thermochemical sodium sulfate process, alternatively could be retained in the sludge to be used as fertilizer after stabilization. Until now, biological methods for recovery have been poorly explored. Reduction is well known. Reduction of small sulfide. Sulfide can exist in water as hydrogen sulfide, bisulfide, species insoluble with metals. Then upstream release from chemically treated waste, activated sludge, and thermally hydrolyzed digestate in laboratory scale digester. The sewage sludge was used for inoculant and experimental tests, was collected from a municipal wastewater treatment plant located in Nola, characterized by its conventional pre-identification system as biological phase. The sludge was collected from the pre-thickening stage, placed ahead of anaerobic digestion. The composition of the sludge substrate used during their experimental activities was quite homogeneous and characterized by the following values: pH 773 for solid and volatile solid, color code, soluble chemical oxygen demand, and phosphate. The sludge was sparked with an extra 1 gram per liter phosphate supplemented as iron phosphate to stimulate the occurrence of chemical precipitation. All experiments were performed under batch conditions and in 500 milliliters bolus-colored glass bottles. Each bottle was filled with 300 milliliters of thickened sludge and sulfate, dosed in different concentrations. All bottles were sealed with caps, allowing both gas and liquid bottling in thermostatic bath at 35 degrees. Phosphate released during anaerobic digestion. Anaerobic tests were performed with phosphate-sparked sewage sludge, and these stopped for after 15 days of further process was observed. The methane production was monitored in 2021 in the bottles from 0 to 400,000 milligrams. Phosphate digestate was two glass bottles. The optimal composition was 7 pH 7 and volatile solid from 15 and curd chemical oxygen down 173 milligrams per liter. The first anaerobic tests were anaerobic tests with sewage sludge. All bottles were placed in 19 degrees for limited duration. Then was calculation of ferric potassium. The ferric potassium was sludge and sludge of potassium overall release occurring from interaction with can be expressed as the sum of equation of 1 and 2. Analytical methods, sludge and phosphate were measured by chromatography, statistical method, and sewage sludge Ferrara image. Although this phosphate release of traction was sulfate, the environmental stage, the acid sewage sludge, particular study that hydroxide pilot and on current market requirements. However, it should be noted that pH speciation in liquid and phase influences survive the phosphate. This attention pre-recovery from renewable sludge, showing promising results when applied to sludge generated in wastewater treatment plant. Is implemented, the obtained results indicate pre-recovery from sludge digested as the most promising process configuration as it enables keeping anaerobic digesters separate biodegradable. Iron phosphate release from phosphate ion, in fact, prior to to base a sewage reactor. This case implementation of the biosulfological sulfate reduction is crucial in this case, saving the reduced sludge disposal and improved recovery, commercialization of solid products rich fertilizer products. That's all what I wanted to say. Thank you very much for listening to me.